Hi there, Physics 131. This is a very brief overview of today's assigned reading. So there's only one section today. It's section 4.3 on friction. But I actually think that this is possibly one of the most difficult, conceptually difficult sections in the whole textbook. And also, I want to say that there's two kinds of friction. There's static friction and kinetic friction. And the author starts with static friction and then talks about kinetic friction. That is the opposite way that I would have written this book, because kinetic friction, I like to start with the easy and then get a little harder. Kinetic friction is very easy, and static friction is quite difficult. So let's just skip ahead, actually, and go to kinetic friction quickly, just so I can... So this is actually pretty simple, which is that if you rub two surfaces against each other, there's a slowing force. And there is something called mu sub k, the coefficient of kinetic friction, which is a dimensionless number which relates to surfaces. And so if an object slides along a surface, then there's a force on the object parallel to the surface, which opposes the motion of the object. So the kinetic friction force depends on the surfaces themselves, so which is represented by this mu sub k number, and relates to the magnitude of the normal force, N. So simply speaking, the friction is equal to mu times the normal force. And that's all there is to it. It's a nice simple equation, and what causes it is tiny little bumps on the two surfaces. So if this box is sliding to the right, then all these little collisions between the bumps on the bottom surface of the box and the bumps on the table will cause a force parallel to the surface, which will slow down the box. It's as simple as that. Now, scrolling back up to the top of this chapter, we get to static friction, which is less simple, I think. But basically it's this, is that if there's a block sitting on a table and you pull it a little, it might not move. And what's going on there is the surface is exerting a force on the box, which I guess would be diagonal, but you can split the surface on the box force into two components. One is perpendicular to the surface, we call that the normal force, and the other is parallel to the surface, and we call that the static friction force. And they're both variable, they depend on all the external forces that are on that object. So that's why it's a little tricky. If you're pushing on this box, that will change the static friction force from the surface on the box and the normal force. So they talk a lot about notation. There's this idea that static friction is actually what helps you walk or run. So if you want to accelerate towards, or want to slow down, I guess, accelerate towards the left, then you plant your foot and it slows you down if you're already walking. If you want to actually speed up, then the force of static friction is actually what pushes you forward. And if you're just standing still, the static friction force can go to zero. So it all depends on what you're doing with your body, what the static friction force is. And that's why I think static friction is the more complicated force, as there's no easy equation for it. It is whatever is needed to keep the surfaces from slipping. Whereas kinetic friction had that beautiful little equation you could use. Okay. And then there's this maximum static friction force. There is an equation for that. It comes up sometimes, like if something's just about to slip, I think, where's the equation? It takes you a while to introduce it. It's somewhere, here it is. The static friction force is greater than or equal to 0 and less than or equal to mu sub s times normal force. So, and that's actually kind of similar in style to the real equation for kinetic friction force, and that's why it gets students kind of confused. There is no equation for static friction force, but we know it's less than mu sub s times n. So there's an equation for the maximum. And then there's a nice little table here which lists various coefficients of static friction and kinetic friction for a lot of different contacting surfaces. So like steel on steel, aluminum on steel, wood on wood, I think we're going to use in the pre-class quiz. And what you notice is that the coefficients of static friction is always greater than the coefficients of kinetic friction. So once something gets sliding, the force of kinetic friction is less than whatever the maximum static friction was to keep it from sliding. So definitely read through this chapter. There's a nice example at the very end with something on a hill, which you should go through. And that's it for today. See you next time. Bye for now.